I can't tell you how many times I've heard a student say, I can't do word problems, they don't make sense to me. And at the same time I hear people say, well, math doesn't relate to the real world. Well, if you don't understand how applications work, which means you don't understand how to do word problems, then of course you don't see why math affects the real world. So what I want to do is give a nice strategy to solving problems and then showing you an example of how that works. Okay, now when you encounter a word problem, step one is to make sure that you read it well. Read it carefully. Identify what you don't know. Identify what is known. Step two is, if it's possible, draw a picture that relates the situation. To me, seeing the visual helps make these quantities make more sense. Step three is finding an equation that relates the things involved in the question. Find an equation that relates the things you don't know to what you do know. Okay, step four is finally solve that equation. Okay, so this is what we try to do in step one, but it doesn't work. You need to follow this process. And step five, please just think about your answer. Stop and think. Does this make sense? Does this answer seem like it's in the scale of what I'm talking about? I believe that if you follow this strategy, that word problems will get less confusing, make more sense, and mathematics as a whole will become more vibrant. Here we have an example of an application problem that can be solved with a linear equation, and I'm using it as an example to go over the 5-part process that I just talked about. Alright, so part 1 of our process said to read the question well. Here it says the distance from Tulsa, Oklahoma to Nashville, Tennessee by one route is 610 miles. If Janet made the trip in 9.5 hours, what was her average speed? Alright, so let's read it again, but this time let's identify what we know and what we don't know. So it says the distance from Tulsa to Nashville by one route is 610 miles. That 610 miles is something I know, and I know that that number relates to a distance. So I'm going to say distance is 610 miles. Now if Janet made the trip in 9.5 hours, that's something else I know. I know 9.5 hours is a time, so I'm going to say 9.5 hours. If you want to use fractions, you can. That's 9.5 hours. Or if you don't like mixed fractions, like I don't, you can say that's 18.5 plus 1/2 gives you 19 over 2 hours. So those are all representing the same thing. And the question we're asking for is our average speed. So that's my rate. That's what I'm looking for. Okay, now part 2 is we said let's make a picture of this to figure out what's going on. Okay, so here I have Oklahoma over here, something kind of like this. And then here's the Arkansas-Missouri border, and Tennessee kind of comes up here like this, something along that, like that. And Tulsa's over here, and Nashville's over here. And we're going straight. Well, we have a route that's 610 miles, so we'll just represent that as a straight bar. There's my distance. And I know that the time it takes Janet to travel this is my time of 9.5, so something like that. Okay, so for me, the picture just helps identify what's going on. Okay, so now part 3 said, let's actually find our equation. And this is what people try to jump to at first a lot, but if you go through steps 1 and 2, it helps you correctly identify what we need. Okay, so I got to figure out a way to relate distance with rate and time. And I think a good way to illustrate this is through an example. Let's say I said, hey, I'm going 30 miles an hour for 3 hours. How far did I go? Well, we understand then that means I went 30 miles an hour for 3 hours. That's going to be 90 miles. So what I did there is I related distance to be the time times the rate. I went 30 miles an hour for 3 hours. That gave me a distance. So in this question, I know distance is 610. I know time is 9.5, and I don't know r. That's what I'm looking for. So I have my linear equation. So for 4, all I have to do then is solve this linear equation. And the way you solve an equation like this is just by dividing by 9.5 on both sides to give me r. And you'll need to put this in a calculator, and you'll get a value of about 64.21 miles per hour. Right? I divided miles by hours should give me miles per hour, or mph is a more common way of saying this. And so I think that's my answer. But now what I need to do is sit there and make sure, does this seem logical? And so 5, I ask myself, does this make sense? And I think it does. I mean, 64 miles per hour is not unusual in my mind of traveling across the United States. So, what if I had accidentally typed in my calculator? So, for example, what if I had accidentally typed in 610 divided by 0.95? So I misplaced my decimal, and I got an answer of something like this: 579.5 miles per hour. Now, I've actually gotten answers like this from students before, but this is why you want to think back to part 5. Does this make sense? Have you ever gotten in a car and traveled 580 miles per hour? Probably not. That doesn't make sense to me. So because of that, I would say I messed up somewhere. I need to go back and make sure this makes sense. 64.21 miles is very reasonable. I'm going to show you a few more videos on the applications of linear equations, but this problem-solving technique will apply beyond just linear equations. If you have any questions, let me know. I'll be glad to help, and thanks for watching.